The web, if you didn't know this, the web has become the largest infection vector for malware, with email slightly behind it. And there are a number of ways that malware can infect a user's computer from the web. There are drive-by downloads, websites that the user just happens to click on, or even possibly not even clicking on, their browser happens to hit, and it automatically exploits and installs malware into the browser or on your machine. There are tons of fake security software sites, antivirus 2008, antivirus 2009. If you've never looked at it, check out the malware database. If you Google it, you'll find it. The guy who runs it, Lithium, he maintains a huge list of illicit security software on the web where it actually gets installed. It's actually malware. It's going to install more malware onto your system and just really screw it up. And finally, there are attack toolkits out there specifically made to infect your system. They're very well made. They're web-based. They will launch multiple attacks against a browser. They'll actually determine what operating system, what browser, and plugins that the person hitting the site have installed, and customize the exploits based off of that, just so they can get their malware on your system. So, and these are only 3 of the possible ways. Google has a great paper out called "The Ghost in the Browser," which goes into a lot of detail on how the browser can be exploited to install malware. Now, as investigators or analysts or security people working in corporations or whatever organization you're in, eventually you're going to come across the problem where web-based malware has gotten onto a system under your control. Unfortunately, the trend has been that antivirus is going to be of little help. There is a definite period of time between when a piece of malware is released and when it's reliably detected by antivirus. And unfortunately, that time period appears to be growing. So in my research, there's at least 3 to 7 days of time lapse between when a piece of malware is released on the web and starts infecting systems to when your antivirus provider is going to detect that. And even when it detects it, there's no guarantee that your antivirus is going to completely remove it or remove the other things that that piece of malware had already downloaded and installed onto that PC. Because of this, manual analysis of the malware may be required. You may need to actually go in and see what the malware does, what files it drops, what registry entries it hits, and so on, in order to determine how to get it off your system. And of course, since this is an investigation, you don't know what the malware is doing. Time is of the essence. You need to get in there and be able to figure out what's going on very, very quickly. Now, like I said, malware analysis has a number of problems on its own. The malware could be packed, which makes it more difficult to analyze. It could have anti-debugging or anti-virtual machine or anti-analysis capabilities built into it so that when you start using your tools to analyze this malware, it just automatically shuts down or does something completely benign. Web-based malware has a number of its own problems. The first is many of the exploits that actually infect your machine and tell where the malware is downloaded from are often hidden with obfuscated JavaScript. This isn't always the easiest thing to decode. There are some tools, some great tools out there like Caffeine Monkey and Malzilla, which will help you in de-obfuscating the JavaScript so you can see what's going on. The problem, though, is attackers realize this, and so they're starting to create obfuscated JavaScript, which is browser dependent. And what I mean by that is they're using JavaScript code and using mathematical algorithms within that JavaScript, which have different results based on whether you're using Internet Explorer or Firefox. And since Caffeine Monkey and Malzilla are based off of SpiderMonkey, which is the JavaScript engine for Firefox, if the obfuscated JavaScript is using a mathematical algorithm, which only Internet Explorer will resolve correctly, your obfuscated JavaScript you may not be able to figure out what your obfuscated JavaScript is doing. So you may run into a problem with that. Malware authors, or the bad guys putting up the malware on the web, are smart. They know that we as analysts are going out and downloading their malware to analyze it. Therefore, they're creating what I'm terming as one-shot infections, meaning you have one chance to go and get that malware off that website. And any subsequent attempt to grab that malware off the website results in a redirect to a benign page or just a 404 page that doesn't show you where the malware is. So you have one shot in order to grab that malware to analyze it. If you miss that shot or you screw it up, you're screwed. And they're doing this a number of ways. They're doing it via firewall-based capabilities where they see an IP address come in and they just blacklist it after the first attempt. They're doing it cookie-based, which you can get around, but they're getting pretty smart at this. They're having browser header requirements when you go to get their malware. So if you don't have a specific user agent or referrer in your browser header when you go to get the malware, you're going to be redirected to a benign site. It may have browser or plugin dependencies. So if you're not running Flash or you're not running some Adobe plugin or plugin X, or you're not running IE or Opera or the specific browser it's looking for, it's not going to serve you up the malware. And again, you don't know how far down the rabbit hole this malware infection goes. I've seen many sites where you go to one site and there's an iframe pointing to a second site, and on that second site there's another iframe pointing to a third site and to a fourth site, and then finally on the fifth site is where you get the infection. So just by hitting the first site, you may not be getting the actual infection, or you may not be able to find the malware. You have to go down 5 or 6 sites in order to figure out where that malware actually is. So with all these problems, we need a solution which is going to automatically analyze the malware in its natural environment being the browser. We need to somehow create an environment that we control for malware analysis that's going to use the browser to go out to this infection site or whatever infection site we find to automatically download the browser as a normal user would. Well, SANnets are an excellent resource or an excellent tool for doing this. SANnets are essentially a virtual network for running programs safely. If you know what a sandbox is a single program or container or system which is used to execute programs in a safe environment. Sandbox IE is a great example of this. It encapsulates Internet Explorer, whatever program you want, into its own virtual container, and nothing can get out. Well, SANnets expand this a little bit. They take it one step further where you have two systems, two components, where you have the sandbox being the system that we're going to run the malicious code on, and then a network simulator. And I'll talk a little bit more about the network simulator, but essentially what it does is it emulates the internet, or whatever network you want. If you want to go to a website, it's going to say, I'm that website. If you want to go to an IRC server, it's going to say, I'm that IRC server, and act like that, and then respond back and pretend to be whatever you want it to be. In a true SANnet, there is no contact with the outside world. It is totally segmented from any other network. There are two types of SANnets. You can go physical, where you actually have two physical machines which are acting as the sandbox and the network simulator, or you can go virtual, where you're using a virtual machine to act as the sandbox and the network simulator as all in one encompassing machine, or let's say two VMware sessions which act as the sandbox and the network simulator. And there are disadvantages and advantages to both. The great thing about SANnets is it allows you to automate the malware analysis process. You control this environment. You control everything within it. And so you can automate it going out to wherever you want it to go.